About 20 years ago, if we were writing software, we'd have to spend a lot of manual time figuring out where the software comes from, how to get it all compiling, and then finally figure out how to share it and publish it for other people. What Docker did was to unify this entire workflow. So I can write a single Docker file that lets me build software from lots of different sources, run it on my computer or on the cloud, and finally publish it socially as well for other people.
The main points of the article are really about how Docker containers unlocks a vast library of existing software for more people. The paper is really about how we made this happen, all the various challenges that we had to overcome to make this seamless experience.
And by pulling all of these things into one workflow mechanism, we unlock the ability for people to share open source software across lots of different languages and to really get on with the productive business of writing software to solve real problems. The reason this is important is that we're just stronger if we work together. If a developer just wanted to quickly try out someone else's software, they could just pull a Docker file. If they wanted to then publish their changes, they could publish the incremental differences on the Docker Hub. And then finally, all of this formed a virtuous cycle where millions and millions of people decided to do the same thing. And we ended up collaboratively developing a huge amount of internet software. And the open source movement has been all about building small components that we can all then reuse and ultimately form a very, very complicated web of software that works and is reliable and is used in some pretty mission-critical use cases.
For example, NASA gave a talk at a conference talking about how their DART project, which was designed to nudge asteroids out of position if they were heading towards the Earth. And so obviously they've got a mission which is to save everyone from extinction. And Docker was able to help in a very small way by helping them package up their simulation software so that they could easily share it with other developers in the project.
If you think about software, we use it in all parts of digital society these days, ranging from my grandma's website all the way to nuclear power plants, to wearable devices, and all of these depend on lots and lots of different bits of software. Now, because there's no one perfect way to build software, Docker said it's not going to take a decision on exactly how you do things, but it's going to empower you to build an environment where you can develop the bit of software you want to focus on.
What's new or different? Well, I think the challenges around making Docker work on non-Linux systems were particularly interesting. Previously, you had to run a separate virtual machine software tool and then start a VM and then run your Docker containers in it. Quite high friction, quite complicated, but we turned this complicated thing into a little library, embedded it in the application. No one needs to even know it's there, but it's there, and whenever you start a container, it starts a VM transparently, you don't even see it, and so you're able to use that. It's just a seamless experience, even though it's not running Linux kernel on the host, it's running Linux in the VM.
Today, we're living in a very different world, and there are new challenges up and coming because the way the software is written is changing fundamentally. Security is really, really crucial because we have more and more secrets that can affect our lives that are intermingled with the software. And so Docker is adding support for confidential computing, for hardware enclaves, such that it can seamlessly partition the bits that you want to keep secret and the bits you want to keep private away from the public data. And finally, the huge wave that is changing the way that all of us program is AI. And Docker is adding support for seamless local workflows so that you can use AI coding agents. They can generate huge amounts of code, but you can keep it secure, sandboxed, and under control so you can decide what to share with the wider world and what you're using for yourself as well. While Docker has been transformative for software development, my personal passion is environmental science. How do we deal with biodiversity and climate change? So what I'm doing with Docker is I'm adding in support for planetary computing. So this is the ability to share maps and labels and directions and spottings of wildlife in such a way that anyone can program these things so you can learn more about how nature works near you. And we're hoping that we can build this on top of Docker in order to make it really easy to build a planetary Wikipedia for everyone to know what's going on around them.